Hello, welcome to the second episode of CosmWasm by Dummies, which is a beginner-focused stream that Callum and I are doing to help get folks up to speed with CosmWasm and all of its goodness. There's currently a heat wave in the UK, and British people aren't good at dealing with heat, so that's why both of us look a little bit hot and bothered. So apologies about that in advance.
We're just a bit shinier today.
We are a little bit more metallic. Don't worry, we haven't been replaced by the T1000. Or is it T2000? I can never remember with the ordering system for Terminator models. One of the two.
Better than our versioning still, though. So
exactly. So in this one, we're basically going to go through building on what we did in the last stream, where we sort of set up a local dev environment, got that rolling, and looked at some of the things involved. We're going to use the CosmWasm into Wasm example template to show the process of essentially deploying a contract to a locally running chain on your development machine. So if you've worked with any kind of back-end sort of web development framework before, you've probably gone through a similar sort of deployment workflow while developing code. And so hopefully you'll see very quickly how this flow can literally be automated into a bash script or however you prefer to work. And you can just sort of like run that and bish, bash, bosh. You can get a pretty smooth development workflow going. Particularly important as you start to think about working on front ends, that you can like make some changes on the back end, change your front end and see all the things kind of reflected, especially on the query side, which we'll get to in a minute. You'll find that you'll be making a lot of changes and then needing to go through these steps. So you will want to automate them. And so first of all, I guess we want to show, before we move on, we want to talk a little bit about the contract lifecycle. It has, I suppose, two most important things for us at this stage. There is storing and instantiating. Callum, pop quiz. What are those two things and why should people care about them?
So storing the contract is the process of uploading the contract to a chain, and it will be then uploading the bytecode, the WASM bytecode to a chain, and then you will return it will return you a numeric identifier, which for this purpose, as we're running on a local chain, it will be 1 because we're just uploading the first contract on chain. And then that will then be used to, you can then go, let's instantiate builds on that. You can instantiate a code ID so it can find the bytecode you want to instantiate along with a message to sort of instantiate and build your contract, sort of similar to a constructor in sort of object-oriented models, or just sort of creating an object. So yeah, these two go very hand in hand. You'll quite often, in our automation bash scripts, we upload our contracts and then instantly instantiate them, say for Howl or the name service, in like a workflow, just to check that we can that they upload correctly.
Yeah, and there are other things that people might be familiar with, like the Unity contract on Juno and things like that. Again, there are continuous integration workflows for these that use a very similar structure to what we're going to do, except these steps that are encoded in the show notes are in a bash script. That's basically the only difference. And you can do that to test anything from straight up, does my contract instantiate? Is there a regression? All the way to much more complicated things like, to use the Unity contract as an example, governance-based action was taken against a pseudo contract. So yeah, that's basically how that works. So there's the final bit. So we've talked about instantiation and we've talked about storing. So I should say storing and then instantiation, because that's the correct order. There's one final one which we won't cover today, which is migration. And that's essentially the process of changing the running code to a new version of the code. So that will be important because we're going to talk about how you interact with these as well. And the primary way that you interact with one of these contracts is via an entry point. And as you've guessed, we're not going to talk about migration, but migration is an entry point, just like the other ones that we're going to talk about today. Sudo is also an entry point that we're not going to talk about today, but that's, again, you might have heard of that in the context of the Unity contract, which is governance can take some actions on certain contracts, and that's a different type of action from the ones we're going to be covering today. The ones we're going to be covering today are querying and executing, which are probably the two most common entry points that you will see. So we've prepared a little. Callum's laughing because he knows what's coming. We've prepared a little diagram.
I'm laughing at the comment we just got. No migration, typical, and then the UK flag is. That one really tickled me.
Okay, that is actually very funny. Well done, Archie. You've got a chuckle. Okay, so the things we're going to be talking about today are executing and querying, and implicitly state, because I think we alluded to earlier that this is the contract part that's running on the chain effectively takes the place of a backend or a web server, if you like. Instead of HTTP, instead of REST, we're going to interact with the contract via an RPC API, which might be a bit different if you're very, very familiar with REST APIs. But the concept is basically the same. It's a backend. An RPC endpoint is providing you with your web server, and the code that we're going to see is essentially like a database layer. It's like a database driver or something like that. Is that a reasonable description?
Yeah, because quite a lot of it is abstracted away, but effectively the state is just, the underlying bytes. But luckily CosmWasm comes with, in older versions of CosmWasm, like 0.16, so if you're familiar with Terra, you had to sort of wrangle the bytes yourself. But nowadays with modern CosmWasm, CW Storage Plus sort of allows you to store quite complex structures as long as they can serialize, which most of them can. So yeah, like sort of your state is your underlying storage that you will query, you will read and write to. Sort of, yeah, you can have quite simple CRUD applications, or you can take some quite complex actions.
I've just noticed we've had another question as well. Andre asked, using the same OO analogy, so OO, in this case, assuming object-oriented programming, says it will be like a singleton. That means after you instantiate the contract. It won't be quite like a singleton. It will be more like a regular instance, because you can instantiate a contract any number of times. So a really good example of this would be CW721 contract, where you might store that on chain, and then multiple people might, say, release additions, right? But they might have very fundamentally different mints that they're using that contract to then run. But it would all come off of the same bytecode, potentially.
Yeah, like the bytecode is like the blueprint, and then you instantiate it for a specific instance. My lecturer, for when we're learning OOP, as flawed as it is, he said, think of a class like a blueprint, and then when you create an object, that is the implementation of that blueprint. Sort of, yeah, but this is the same here. You can have CW20s. There's loads of CW20s on Juno that just point to the same code ID, which is code ID 1 on the mainnet. So yeah.
Good knowledge. Okay, so we've alluded to the fact that we're mainly going to be dealing with, we're obviously going to deal with that part of the life cycle, so storing and instantiating. What do you do after that? Well, you get to actually interact with your contract. And as alluded to, we're going to talk about two of the primary ways that you interact with the contract today, and we're going to show you how you do them. As we mentioned, you're going to interact with them via an RPC endpoint, which means passing them a JSON payload. Again, pretty familiar. But what we're going to do in this example is we're going to be doing that via the CLI, rather than via HTTP, right? So by the time you build out a front end, you're going to be doing it sort of over an HTTP client. But when you're just experimenting your own machine, doing local dev, you're much more likely to use the CLI. The CLI is just a wrapper to call a known RPC endpoint. So if you were to run, in fact, I can literally show you this if I could find my terminal. Oh no, I can't yet because I haven't done the steps that I can need to show you. Okay, so you just have to believe me that if I did any of the steps I'm going to show you later without a running version of the actual chain deployment environment, and crucially an RPC available for it, the command line instruction would error because it can't actually interact with the thing. as you can intuit, right? If there's nothing for it to call. But this is all just to say it's HTTP under the hood, okay? So on to the most relevant bit of this. How does that actually work? What is that life cycle? Why is it important? We've got our rip-off Google Chrome logo here, as Callum called it earlier. So first of all, we need to write, like we were talking about, as a storage layer. All these contracts are just a storage layer. Eventually, some data ends up stored on a database substrate. In this case, it's a blockchain, but it could be anything. So we're writing on that side. Then that's, once something is persisted, that enters into state, and then we kind of read it out again. So yeah, essentially, like, if you think about a user submitting a form, that's a write. State is then the data that's persisted, so that if they go off somewhere else, go have a sandwich, do whatever people do, and then they come back, their data's still going to be there because it was persisted to state. And the reason we can show them that data again is because we'll read it back out of that storage, that state, right? So, and for those of you that are kind of minded to think about fundamentals of computation, I don't know if there are many people on the stream that think about that, you will have also spotted that essentially your runtime is handling the read and write, and the state is like an external thing. So whenever you have side effects from a program, anything that's not computationally pure, that's usually because some information is being stored somewhere else that's kind of static versus the runtime of the program. Why is this important for what we're doing? We're not going to need to deal with this problem, but it is worth remembering that we need determinism in order to not break consensus, right? So those of you that remember the chain halt on Juno, that was caused by actually using this same template contract that we're about to see, but injecting some malicious code in it. What the malicious code did was read the current node and then save that node to storage, so that when that was then read, every single node would say, yeah, the answer to this result is this thing, and all 125 nodes in the network returned a different result, causing a fork. Well, causing 125 forks, right? So this is why side effects are important. This is why determinism is important. But that's really a detail for another day. In terms of a CosmWasm contract, there are two entry points that deal with the parts of the pie that we saw just then. Write and read are handled by execute and query, respectively. So whenever you see execute, think storing data. Whenever you see query, think reading data. And then state is just the data at rest, right? And the bit that, as Callum said, there's a previous version of CosmWasm that was used on Old Terra, which was, it had some, well, it was actually, to be fair, the Storage Plus, but it had some inconsistencies with current version of Storage Plus. But Storage Plus is essentially an abstraction layer that gives you some of the features of a NoSQL database for you to work with. And this is like really important for kind of the developer ergonomics of CosmWasm, because it means that you can do stuff that you would be familiar with in, I don't know, Mongo, whatever. Pick a NoSQL data store. I mean, pick Postgres. It's basically NoSQL at this point. You can do it. And use those features to build an actual application, and use the performance characteristics that you can kind of lean on to reason about those same types of database storage, right? So query and execute are what we're going to be focusing on here, as well as those store and instantiate steps that we need to do before we can even interact with the contract, okay? So that was me talking for quite a bit. Callum, do you have anything to add? Sorry about that.
Not really. I think you did quite a good job there. But yeah, quite often you'll find a lot of the common actions you'll do. Storage Plus has just really helpful wrappers for. And if you go back to the older versions of CosmWasm, like I alluded to, it was a lot of sort of manually moving bytes around and decoding and encoding. But yeah, Storage Plus is now quite mature, I'd say. It has quite a lot of common actions that you'd want to perform. And this just makes, as Frey said, the whole ergonomics of CosmWasm just so much more easier and nice to use. But yeah, that's my points.
Okay, so now we're going to flick over to the terminal, and we're going to actually get some stuff running. So we'll come back to these two messages that we can see here. So as we were talking about, there's several entry points that we care about. Execute, query being the ones we're going to deal with right now, and we can see these are some of them. This looks overwhelming. Don't worry about it just now. We will come back to it. But you can see that how some of these messages begin to be defined in the Rust code here. And again, we'll come back to them in a little bit once we've actually deployed this contract. But you can also see really, really easily, if you just want to scan through anybody else's code, even if you're not really interested in writing your own contracts, but you just want to look at somebody else's code and kind of have an idea of what you're looking at. Looking for this guy here in macros in a contract is a really good way to start, because you'll see all of the different entry points in the contract. In this case, instantiates there, execute is down there, query is down there. That's it. There isn't a sudo, and there isn't a migrate. There's there's reply as well, which we definitely are not covering in this one, but it's worth being aware that that is an entry point as well. Okay, let's do some fun stuff. So in the last episode, we covered launching a local chain. We used Docker Compose, and we used this magic incantation. If you're on a very recent version of Docker, you might not need the hyphen between Docker and Compose. This is actually a brand new dev laptop that I set up this week, and it still takes the hyphen, so that's what I'm going to use because I'm old, I guess.
Old habits die hard.
Old habits die hard, and hopefully this is going to work because, again, it's a new laptop, so it might fall over. Let's run a chain.
And we're getting blocks. Yeah, there we go.
We're getting blocks. Okay, cool. Thank goodness for that. That would have been embarrassing otherwise. 3. Okay, cool. Right, we're definitely getting blocks. So I should probably check my notes. We're now yeah, okay. We now need to actually do some CosmWasm. Okay. So first of all, check you've got cargo installed. Yeah. Second of all, check you can spell cargo.
If you don't have cargo, you can get the Rust tool set here. I've linked that in the chat because I noticed that was missing from the gist.
Yeah, exactly. Yeah, so if you go, you get Rust up, that will set you up with all the basics you need. Then I've already done the next couple of steps, so I don't need to do them, but you'll need to do cargo install, cargo generate, features vendor OpenSSL, and you'll also need to do cargo install. Again, can't spell, cargo run script. These two will allow us to run the CosmWasm template. So once you've done those two, you should be good to go. If you try and run the next step and it errors, it's probably because you haven't got those two steps squared away. So that's the first place to look. And then we can do the step of actually instantiating. Sorry, not instantiating. We're going to create a new project based on the template. This looks like quite a lot is going on. It's really, really not. It's just saying, okay, from this Git repo, use that as a template target and create something with the name Dummies example. So if we do that very quickly, it'll go. Yeah, sorry, it's really hot here right now. And then if you go into that, you'll see you have a brand new CosmWasm project. Hooray! Some useful things you might need to know. Before you do anything, most editors will complain a bit, unless you do cargo build, unless you're using like IntelliJ. Actually, fair, even Emacs doesn't give a shit. I don't know. I'm completely wrong about this. I always run cargo build, but actually most editors, including Emacs, including IntelliJ, including Sublime probably, will actually just build the project for you the first time you hit save. So you probably don't need to do that. A very useful one to know about is cargo schema, which creates all of the JSON schema files for the project. One of the things that this template is good for is that it actually ships with some CI steps for you already. In particular, one of these is called Clippy. Now, if you're not familiar with cargo, Clippy is kind of the very, very opinionated best practice tool, and it is very opinionated. So the great thing about this project is you literally push it to your own GitHub, and it will already have GitHub CI set up for you with actions, with linting, with building, with running your tests. That's fucking cool. The bad thing is that if you forget to run cargo schema, which makes sure your schema is up to date for all of the JSON schemas, or if you forget to run cargo Clippy, you're going to have a bad time because
prepare to get a lot of emails.
You're going to push your code, and then you're going to get well, depending on what GitHub notifications you have set up, you're going to get an email saying, "Yo, your code is slightly formatted wrong, therefore I failed your build. Thanks, Clippy." And so, yeah, that's something worth knowing about. Can you remember what the Clippy command is, Callum?
Cargo Clippy -- all -- targets -- D warnings.
I thought it was just.
I can type it out. 1 second.
Isn't it just that?
I mean, this is the one that I always run, just because it covers the test cases as well. It's this.
Okay, yeah, because of course test cases are in their own particular bit, aren't they?
I put it in the chat. I can also add it.
Oh,
I put it in the private one as well.
It's in the other chat. It's in the secret chat. Okay, cool. So yeah, you could do that. There's no. I don't. To be fair, I was going to say there's nothing. We haven't changed anything, so there's nothing that can go wrong. But that's a bold assumption. Let's run it to see if something does actually go wrong. So yeah, so you've got to build your code first before it can run Clippy, obviously. So this is going to take a hot minute.
First time will take a bit, but afterwards it gets a lot faster. But yeah.
Yeah, 100%.
God, your shiny new Mac handled that really well. That was very fast.
I mean, it is. This Mac is an absolute framework. It's stacked. So yeah, it didn't throw any errors. It just went undone. So there, you're basically good. Not very dramatic, but that's what we're doing. So yeah, I'm actually not sure that was the correct. I'm pretty sure actually that is the correct Clippy for a workspace and not for a single project. But that's another story for another day. So let us stick this on chain. What we're going to do now is we're going to first set up some transactions. So we're going to have to, so there are two transactions that we're going to need to do against the chain in order to store this and work with it. Store and instantiate. You will notice we're going to be talking about storing and instantiating a lot during the next few minutes. But those are both transaction types against the WASM module of the chain, right? So they are very gas heavy, these operations, because you're storing a load of bytecode. So just YOLOing it is not going to work with like default gas settings. It's just not going to work. So we have some custom settings here. These are taken from something linked in the docs, and they're also linked in the show notes. So, but we'll just quickly explain what's going on here. The gas prices we're overriding with a higher default value, substantially higher actually, because just can't be bothered with it failing. We're adjust it. Well, but yeah, so gas is like a window, so we're also adjusting that upwards, hence the 1.3. We're passing b block to the command line, which says call the RPC, but block, don't do it asynchronously, because CLI requests are asynchronous by default. So it will go, cool, but you won't actually see the result of that on the CLI. We're passing the block command to say, wait, give us a proper response. Chain ID is testing. This is the same one we added last week. So we know that default ID for the chain is that on your local machine. And then node is simply, localhost 26656 is the consensus port. 133 something is the RPC port. Can't remember. No, not RPC. It's the REST, the LCD API port. And 26657 is the RPC port by default. So obviously you can reconfigure those values, but we haven't, so we know it's going to be localhost 26657. So all of that said, this means that basically when we pass these additional flags on the end of all the commands that we do, they should just work rather than we get errors because we're out of gas or blah, 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 blah. So 1317, there you go, usurper in the chat. 1317 is the LCD port. Okay, cool. So now if I still can't spell. If we echo those, I still can't spell. Okay, cool. So we set that up. We're going to need to set up a couple of other things. So we're obviously running Juno in a Docker container. I'm on an M1 Mac, so I can't actually compile Juno at the moment on this machine. Well, I can. It's complicated. I'm not going to. Instead, we're going to work with it only in Docker container. Now, if you are on an Intel machine or Intel machine on Mac or on Linux, you can just build Juno normally on your host, and then because those ports are exposed to the host, you can just do Juno D status, blah, 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 blah. And you can just do all these steps we're about to do with Juno D, and it should just work. However, I can't. So I'm going to do this, which, to be honest, even if you can work with it on the host, you might want to do, because it means you are interacting with exactly the version that is running inside the container. And notice that we are running the tip of main at the moment, so it is the most current version. We could obviously target a specific version, and obviously you can also, rather than use Docker Compose, just run a targeted version with the same instantiation args for the chain itself, right? So by doing this next step here where we specify that we want to exec into the container and then take actions, that means that you can be certain that you're always working with the same version of the binary, which is, again, important for compatibility reasons. Although in practice, at the moment, the tech is so new that the idea of kind of legacy versioning compatibility is just not really a thing, but one day it will be, so it probably makes sense to do it this way, I guess. So there we go, and that will mean that we can basically just do binary blah, and it will treat it as if we, instead of doing Juno D status, we could do we should be able to do. I know.
Oh no.
We've got our first borkage. Interesting. Okay, this is the perils of doing it live. Docker exec. Maybe. Okay, so maybe we were going to have to switch to hot switch to a different laptop. So.
Could you try it in a different terminal? Because sometimes ZSH doesn't work with me with flags like that. I just do exec bash and find out if it does.
That's a good idea. We can also just do. Duh.
So it is there.
So it is there, and it is the correct container name. So, and that is the correct. Is it the correct? So I guess so.
And it is there, like Juno D does.
So June is running. Oh, I guess it is running because we saw it running in the other
Yeah.
window. Gosh. Okay. This feels like it's a new work computer and my shell is screwed up. That sort of feels like the issue. Okay. I'm not they're wildly jazzed about it. However, okay, I'm going to quickly.
You could try a different terminal. Try exec bash and try importing the binary again. ZSH never works for me like this. I always have to switch to bash.
Really?
Yeah, it's so weird. I don't know, but this could just be like a placebo I've done. So you'll need to re-import the binary stuff code.
Just getting it back up. That's weird. I've never had a problem on Intel Macs, but like I say, it's completely new as of the last couple of days. So, and this is again a pretty good example. What was something we were talking about in the last one, wasn't it? Just like somebody was like, "What do you need to know in order to do this stuff?" Stay calm and sometimes Google stuff when it all goes wrong.
Yeah.
Okay. Moment of truth. What's going to happen?
Is it all on? Yeah, there we go. Yeah, you see.
Oh shit, you're right. So okay, so we've just learned something else, which is that there must be there's obviously something going a little bit awry with the additional flags on
ZSH
on OS X. So okay, whatever. So switch to Bash. I'll also add that note in the show notes because this has surprised me. Thank you, Callum, for the quick.
It's just something that I noticed when I was uploading the HAL contracts. I was like, this shouldn't be failing this command. I was like, I'm going to try it on a different terminal, and then it worked.
But it works if I was to put this in a script and run it via Z shell, it would work. But I guess that those arguments are already pre-encoded by that point, aren't they?
Yeah, maybe this is now completely different talk that we could go on for hours.
This is a parsing thing, isn't it? Right. Okay. So we're ready to go. We've just shown that you can do binary status, right? And that then calls into the container and then returns you a response out of it. Happy days. Okay. So we need to compile our code now. And I haven't left myself enough terminals to do this, have I?
Do you want me to talk through sort of compiling and that while you do the compile? Because it is going to take a while.
It's going to take a moment.
Right, this is going to be completely improv. But so when you compile a contract, there is a size limit on chain, and I believe, Frey, but if I'm right, 750 kilobytes, right? Yeah. So roughly around there. But so when you often run, there are multiple ways to compile a contract, and there is one in a workflow which is provided by CW template, which is CosmWasm, and CosmWasm purely doesn't do it optimized. So these contracts will often be a couple megabytes, and of course that's too big for to upload on chain just because of the bytecode size limit. So helpful, and in the README of CW template, it provides a Rust optimizer, and there is also something called the workspace optimizer for a workspace which has multiple contracts. So this optimizer will optimize your contract and sort of shed a lot of that extra weight memory-wise, and it will quite often come quite substantially under the size limit. At least this template one will. And one thing I should get to, which is why as Frey is doing it, is that there is two, because if you have an ARM chip, you have to add that -ARM64 flag to it. But if you don't, there is another one which is in the show notes, which is just Rush dash optimizer. And is it the same flag for Workspace Optimizer? Just on a side point, does that have an ARM equivalent yet? Or yeah, so for Workspace Optimizer, which we won't really cover because we're not writing multiple contracts, this same flag applies. So if you have a M1 Mac, use this. If you do not, if you just have an Intel chip, you can just use the other command, which is literally just remove that ARM64. This will then spin up a Docker container and will pull in the dependencies needed for it. It will build the contract and then optimize the release. And this can sometimes take a while, but now it's the test of how fast Phrase Mac is. But I think I gave sort of a cover. Any questions on that? I've probably just confused a bunch of people. But it's quite often, if you don't understand that massive command, it's you don't have to, just know before you upload on chain, build an optimized release and just run that command and then use that optimized WASM, which will be placed in an artifacts directory in the root of your contract.
Yeah, and the other thing to bear in mind about what Callum was saying about the size you can upload is that more often than not, you don't hit the size limit, you actually hit the gas limit. So if you're watching along, you're going like, well, hang on, what's stopping me just like, especially on if gas is cheap or you're in a bear market, imagine, you could presumably just upload some crap and just DDoS the chain with, store requests. And the way around that is obviously the same as for regular transactions. It's that there's a gas meter on a per block basis, right? And there's also a gas limit for storage. So it's more often the case that you hit that gas limit than any of the other many errors that you can hit. And commonly, the problem is not necessarily your code is super complicated, because as we talked about in the last one in terms of architecture, that you're quite often doing kind of microservice type stuff. The reason that you hit the gas limit or hit upload limits is usually because you brought in external dependencies that are larger. And things like even stuff you would quite typically kind of just lean on, I don't know.
Regex.
Yeah, I was going to say HTTP libraries, and I was like completely irrelevant in our context.
Regex.
Regex. Okay, Regex, really good example. Validation, simple validation libraries that import Regex as a dependency. You're going to bust through the limit, and because it's a big library, it's not massive. It's Rust. Rust is pretty efficient at creating its sort of outputs, but still, you are going. This is why the local Juno is pretty good for one important reason. It sets a gas limit that is equivalent to the same configuration as mainnet. So if it works on your laptop, providing the network isn't super congested, there is no reason why it shouldn't work on both testnet and mainnet. Okay, so that's worth knowing. Yeah, compiled ages ago, by the look of it. Okay, cool.
That was really fast. I'm so used to a workspace optimizer where we have like 5 contracts, and you're like, right, set it off, MacBook fans spin up, and then I go and make a cup of tea.
Yeah. So
and another point that I've just noticed when you ls that, if you use the ARM64 variant, it suffixes the WASM with -ART64, whereas on the other one it won't. It will just have. In this case, it would just be dummies_example.wasm, but that's something you can literally just copy to get rid of. You can move it and just rename it.
Exactly. So this is why in the show notes, you'll see it says WASM binary name rather than a specific name, because you need to basically check. If you're following these steps manually, you need to just sort of check what it's actually spat out. In this case, I wish I'd named it something a bit shorter.
The typo potential here is very dangerous.
I should have called it D, and then that would have been. See, I literally. It's very warm. Just keep complaining about.
And that. Remember to go back a bit more and do the next one as well. Yeah. Oh, no. There's going to be a hidden character in there now.
Can't do that. Okay. I mean, to be fair, it would be the definition of a dummy move to actually be able to misspell dummy. That's kind of ironic. So what we're doing here is, like we were trying to talk about, we're running everything inside a Docker container. So we're copying the artifact we just created into the Docker container. So then we can interact with it properly in our other terminal that we're using bash in, because this might not work. So we'll see. Okay, it looked like it might have worked. So let's just verify that with, where's my cursor? There's my cursor.
Go back to the node, yeah.
Yeah, let's just exec back in, and then do you remember where did I stick it?
You typed it out. It was just
binary.
It was.
Oh, it should be there. Why is it not at root?
No. You're in bash at the minute. You're not in the container. So you need to do docker exec -i juno_node_1/bin/sh again, I think. But it won't be on this because you've switched nodes since you've switched terminals.
To quote I was telling somebody, there's that old Simpsons joke about the guy in the Cayman Islands who's just like, oh, it's so hot, as he divulges all the Krusty's personal information. That's kind of how I feel today. There we go. Okay.
And then ls here, it should be here. Famous last words. There it is. Yeah.
So the system works.
You're not in Vim.
It's so hot. I definitely shouldn't have told him it was an illegal account. Okay, so we've copied that in now. So now we can interact with it from our script, which is in the other window. Okay, so why did I not? Whatever. Okay, so I'm going to have to do some more manual typing, which obviously I fear and loathe, even though I'm not in Las Vegas. Let's do this. So yes, we do. So what we're going to do here is we're going to, inside the running container, basically throw this file. So we moved it into the container, so it's accessible where it's obviously like co-located with where the binary is. If you were running on your own machine and you just open the ports to the host, you don't have to do this step. You could just do juno d txwasm store, that bit, without needing the binary bit, as we said at the top of the show. But we're doing all these steps in Docker, so the entire thing is self-contained. And the big reason for that is when you throw away the Docker container, all the state is gone, and you need to come back and make it again, which is very important if you're developing and you're iterating repeatedly. It's just way easier to throw it away, bring it back, throw it away, bring it back, especially on this new Mac, which is quite quick, as it turns out. So, and we're just capturing we're basically, so the first part here, this bit from here to here, is just saying store it on our local running chain.
Use the validator wallet, which is set up by the Docker Compose up on the keychain. If you're not familiar with sort of a CLI for a Cosmos chain, they come with their own keychain sets. So yeah, that's just set up for you in the container.
Exactly. So we
spit it out in JSON.
Yeah, spit it out in JSON. Otherwise, it will spit out in YAML text, which is obviously not helpful to us. But this means we can then use JQ to interact with it, right? And JQ is basically a tool for sort of, manipulating JSON. So what this should do is then capture the output of the first command pipe to the second command. So store it. That will return a bunch of JSON. Then the pipe instruction, not unfamiliar to any of you that are Linux people, then goes to JQ. We take the bit that we want, which should return the contract code, and then we store it in this variable contract code. We're going to need it in a minute. We know that it's actually going to be 1, or it should be 1. So, moment of truth.
Here we go.
It's 1. Okay, it was stored. Happy days. So you can do a bunch of things now. If you wanted to, you could do
Contract bytecode.
Yeah, I'm thinking of
list contract bytecode. That's it.
List contract bytecode. So there's a whole bunch of things you can do where you basically interact directly with this code now, including, sort of listing bytecode. You can actually download the bytecode as well if that's useful to you. But here we don't really care about these things. We just want to move straight on and turn this into a real running version of the contract. So we're going to need to instantiate it. In order to do that, actually, one more thing before we move on, which I'll just mention because it's in my show notes here, just so you can see it. The Juno binary ships with a known dev users. That validator is created on the fly. Every time you create a container, it'll be different every time. There's a known dev user in the instructions where the mnemonic is public, it's doxed, right? You can instantiate that inside the Docker container to work with as a dev user. So in the last episode, we basically imported that user into Kepler. So those of you watching along, you already have this dev user, and you might be going like, I want to work with that user because I have a balance, I know how it works, I know it exists inside. If you ran one of those scripts where it already gets provisioned with some funds, it's kind of not important as to why, but Juno will provision a user with some funds, including that docs dev user. You can actually import it into the keychain using this command, right? Which is basically just that big long string. It's just a mnemonic, and then it's just piping it to the binary and saying, okay, add this as the test user name, okay, into that binary keychain. So then if you do that, it should work. Yeah, and then you should be able to do, and you'll see that there's the validator and the test user. So if you're building your own app, you're likely going to use the test user, not the validator, in these instructions that we're about to do. So just sort of calling that at this point. So to instantiate, we're going to need some arguments. They're encoded as JSON, and they'll be different for every contract. So in order to find out what these are, we're going to have a look inside our contract. So we want to go, most contracts will have something called like message or something like that. You can also look in schema. So as we mentioned earlier, schema is generated when you run cargo schema, and they're generated from the code to show you what RPC calls are available to you. Instantiate message, that's the one we want. So you can look in here, and it's just standard JSON schema format. So the crucial thing is required. There's only one thing. Count is required. So then we look into the properties to find count. We find count is of type integer, it's int32. And if you want to know where this comes from, you can look in the message.rs file. And again, you can see here we have an instantiate message, pub struct instantiate message. Okay.
Yeah. And the JSON schema is derived from that macro above, and you get used to, if you're defining a macro, adding JSON schema, so you can then export the schema for your users.
Exactly. So we now know what the shape of that instantiate message is going to be, and it looks like this. So it's just, there we go. It's just count, and we're going to instantiate with 42, and then that should be valid JSON. So there we go. And then we actually need to call the instantiate function, which will look like this. Okay. So, Callum, what's going on here? Break it down.
Right, so you've seen the binary before, that's just executing Juno D. So that'll either just be you calling Juno D, or if you're going to have to use it for a Docker container, just using $binary. TX is just a flag, so that there's sub commands and sub commands in sort of Juno D. And these are this is TX because we're wanting to do a transaction, right? And then it's a WASM one, so it's to do with WASM files. We want to instantiate a contract. So that's us, taking the code. So next argument is the contract code. So this is 1. This will just expand to 1. But if there was, say, 5 contracts, you wanted to instantiate contract 3, you'd plug 3 in there. I believe as we speak, there's like 518 contract codes on Juno. So it could be in 1 to 518. Thanks to Security DAO for that stat on Twitter. But yeah, and then in the next argument is in quotes. This is using the argument we just defined above to give it the JSON encoded instantiate message, and we just wrap it in quotes to make sure it all expands properly. We're using the validator wallet, as we say. So, oh no, we want to use the user wallet because this will actually have funds. That was a good spot midway through. Label is sort of a string label that you can use to sort of textually identify a contract. In this case, my first contract will do. We might say if we uploaded a staking contract and it was version 1, we would just put like sort of staking contract v1.0.0. Then we add the transaction flags, which we've already defined, just to set up gas, the block, just to make sure we get it all back. And then this next flag is a bit more interesting. So quite often in a contract, you'll have your own logic, but there is what I call sort of the root WASM admin. And the migrations that we talked about earlier that we're not going to cover yet, that requires this admin to be set. And what this does, this -- no admin, it basically just sets no admin. There is no admin, so this contract will be unmigratable. So once it's uploaded, you won't be able to point the contract that we've instantiated at new WASM bytecode, say if there's a bug or anything. But if you wanted to set an admin, you would just have to do -- admin space and then the address you want to set as an admin, which is quite often sort of your address. It could be a multi-sig, it could be a DAO, it could even be the Juno community pool.
Yeah, which is quite powerful, but it's worth re-emphasizing. If you don't set an admin, the code can never be changed. Like, you could have the worst security vulnerability in the world and you're going to get wrecked. There's nothing you can do about it. So the admin field is probably the single most important of all of these commands, because your model for how you effect code changes is going to be not only something you kind of need to think about as a team of developers or as an individual developer. It's something you need to think about from a governance and ownership perspective. Like, who has the right to upload this code? Maybe more common in the case of like a DAO or a chain itself, or something like Unity or whatever, where it's a multi-sig. Well, actually no. Unity is a good example of one that doesn't have an admin. Actually, now I think about it, I'm pretty sure it doesn't. So yeah, and there are cases where you never want something to be changeable. So you want to lock it away and then never touch it again, other than via the hooks that it exposes. So like Unity, like an escrow, things like that, where only via the interface that's provided in the contract should you ever be able to take actions on it ever again. The most applications that are like normal web applications that we're sort of building or whatever, you're going to need an admin because you need to change the code at some point, right? Cool. So I'm going to hit instantiate and hope for the best. Let's go.
So what this is, just while this is running, it's going to that instantiate endpoint, giving it the instantiate message, and then the instantiate function that we saw in the code is then performing the logic needed to set up and instantiate the contract. And as you can see here highlighted, it returns in this raw log the contract address, which is the address of the contract we've just created. And you can also get this address by running a console command using JQ. Earlier, when we looked at the WASM subcommand, you could see query list contracts by code ID, and you can, which we're now doing, you will then see there should be one contract. Yeah. And the last in that list, if you encode it in JSON, it will just be a list. The last one will always be the latest contract instantiated. So you can sort of use --1 array notation to always get the latest contract if you're using JQ to sort of, if you're writing a bash script to get the contract. Right. So now that this is all set up, at least, but you can see it spits out a Juno address, and I believe the contract Juno address is longer than your standard Juno addresses, as you can see actually by the owner. in the attributes section. I actually don't know the bytes that a contract address uses compared to a normal one, but that's a very rudimentary way to identify a contract.
It's 32, the contract address. So I think the reasoning is basically very easy visual visual spotting that it's a contract and not a user, and being able to reason about it programmatically, right? If it's 32 bytes, it's a contract. If it's 20, it's a user. Excuse me, it's still a back 32. So all of the stuff. So when we kept saying earlier, like you can have like an admin that's like a user, a multi-sig, a DAO, a contract, whatever. So contracts can be admins for other contracts, because obviously a DAO and a multi-sig are both contracts, right? That may not be immediately obvious, but they are, right? So when we say that it is just a 32 byte identifier that has the same kind of general properties as an account, it really does. And that's how you can see. I just purloined this example contract address lookup after what Callum was saying. So you can see here basically this contract -1 is looking in that array and then taking the last one, which will be the correct one in this case, where there's only one instantiation. And I think that will just work actually. So if we
and then you can just echo it.
What am I doing? It's so hot.
I'm dying.
Definitely shouldn't have revealed it was an illegal account. Okay, there you go. So that does work. And I'll put that in the show notes now before I forget, so that you folks can play around with it when you get to that step. So it's worth having a quick recap. I know we're kind of getting up towards the end of our allotted time. So let's have a little recap of what we've done. What have we done?
So what we've done is we've picked up directly from last week. We spun up a local node again using the Docker Compose up. And then what we did is we then, with this node setup, we created our transaction flags to point at our local node so we could then run some console commands. We then generated the boilerplate CW template contract, which is just quite often the easiest way to spin up a new CosmWasm project. We built the optimized binary, which was done via the Docker command. Just remember that there is a ARM variant for M1 chips, and then there's also the normal variant for Intel chips or pre-M1 Macs. There we go. And then once we got this artifact built, we copied it into our Docker container. We then set up our environment to then interact via the Docker container to upload the contract. This was done with our test user wallet and setting some gas limits. After that, we then instantiate the contract. So we needed to create the instantiate message, which we looked in the JSON schema for, or message.rs. You can sort of determine it from either. So in this case, it just had a count argument, which we set to 42. We then instantiated the contract with the count starting at 42. And afterwards, we either looked in the raw log, which is still in front of you here, for the contract address, or we run to the list contract by code command, which is more often than not the better way to find it, in my opinion, because you can quite often get lost in a wall of text if you have a lot of added attributes. So yeah, and this just gave us an address, which we could then use to interact with the contract. And I think, yeah, you're muted, Frey.
Okay, very good summary. So we're only going to do a couple more things here. So we've said now we can interact with this. Let's take it all the way back to our fake Google Chrome logo from earlier, which I need to not call the fake Google Chrome logo because that's how they get you. So we were saying that the meta lifecycle of these contracts is store, instantiate, migrate. I guess if you have an admin set, you can migrate it, right? But when you're actually interacting with them as a user, it's write, read, and then there's this state piece that you don't really see. But that's basically the function of the contract, is to work with the state. So, and that translates to execute, query, and then our state layer, which is provided by CW Storage Plus. So what about query and execute? We've stored, we've instantiated, we haven't done a query or an execute. This is what we're going to do now. So again, flicking between 1,800 different windows to try and make this work. So give me 2 seconds while I get some query action on the go. So we're going to need to do query contract smart, aren't we? Right, so it's going to be, and Callum, please shout if you see me doing it wrong, because
I for sure will.
This is why he's on the team. Okay. CosmWasm query contract smart.
Yeah, that's it.
Contract address, and then
then
there'll be some arguments, but we'll come back to it in a second because I can't remember what they are. And then it will be from test user, because we just made that.
It's a query. It doesn't need a user.
Oh, it doesn't need signing, does it? Okay,
so I think that should just work, and it should just be count in there, and then an empty object,
and then with an empty object on the other side, like that.
Yeah, I believe so. And this is how the chain halted, guys.
It has to be this. Ooh, okay. Unknown
query wasm. 1 second, let me get an example up. Let me look in the how code.
Contract state. Oh, I think it might be contract state, then query contract smart, something like that. Contract state smart, contract state smart.
Oh my god, our deploy local is massive for how I completely forgot.
Yep. There you go. It's that.
Oh yeah, it's CosmWasm list. Oh no, that's the address. Ignore me.
I think it's that. Nope.
Oh, it's binary query wasm contract dash state space smart.
Yeah, no, that's.
Oh, it's git count. It's git count, not count. It was an error in my JSON.
Okay, yeah, sorry.
So it's git count.
So we're motoring along through this, but just so in case you see this yourself and you're like, oh, well, it's blown up. Why? The error was right here at the bottom. It's just saying, okay, this is our query message. That's an enum. We'll talk about that in the next episode when we talk about writing your first smart contract, right? We'll explain what these enums are, why they're important, why you should care about them, why algebraic data types are cool, maybe. And it's saying that fundamentally, so an enum is a collection of variants, right? It's using the word variant, not important what that is at this point. It's saying, look, fundamentally, count doesn't exist. You fucked up, lads. Callum, great, you fucked it. Try again. But it's also saying, helpfully, hey, what about
this? This is one of the few helpful error messages you'll get, by the way. This is about as helpful as it gets.
But as Callum spotted, much quicker than I did, count. So, hey, there we go. That worked. And now, if we do output JSON, we can get it in JSON. So this is our that's our query function, and we're going to return to that in a minute. First of all, we are actually going to now change the state of this contract, and then we are going to run that command again, and you're going to see that it's changed. Hey, so we're going to increment. That's probably the best thing to do, isn't it?
Yeah.
So this contract increment is like a really simple example. It's just a counter contract, so you can just increment or reset the state. Okay, so we instantiated it. Now we're just going to increment. Okay.
Yeah, you can imagine it like a really shit clicker game.
Yeah, exactly. Again, we're gonna look in execute message, and increment has no arguments. And again, you can look in execute message here. You can see required increment properties. It's type object with no additional properties. Okay. So then we can do this. And this time we will need to supply some flags from test user.
Yeah, because this will actually be a transaction on chain, so we need to, we need to pay for gas. Queries have a free gas limit, so yeah.
And I don't know if it actually returns anything useful in this. Key value, sender value. Yeah, no, it doesn't actually tell you what you've done. So we'll need to query again to show what happened. You can see it's gone up to 43. Okay, but maybe we don't like that. So we want to reset this value. Okay, we're going to reset it back to the beginning. We don't like change. So again, we can look here and we can see that there's a different type here called reset that has an object with a count, and it's an I32. So very similar to the instantiation property that we saw earlier. So two.
Yep.
And then we did that. We can see it's reset.
And we're back where we started.
And we're back where we started.
But now you will see.
There's a bit of a summary there.
Yeah. Welcome to development. But yeah, what you'll now see is on the contract. If this was on mainnet, you could go on mint scan and see these transactions interacting with our contract. So you could see we've incremented it once and then we reset it. And this is how actually we were able to trace the chain halt. We saw that this malicious user was incrementing this contract. It was something like 40 plus times, right? So that's why it was a little bit suspicious, because if you're a learner, you often I can understand, counting 3 times, be like, oh, it's going up each time. But once you're done, you're done. But you could kind of notice there was something going on because this contract was being incremented quite a lot.
Yeah, exactly. So what we've done then, all the things that Callum said we did previously, and then the final thing we've added to that is we've added executing, and we've added querying. Now, those things are obviously, we've done them via the CLI, so you're thinking like, how do I now make a UI? How do I now build an application on top of this? Well, as we said right at the beginning, this is using the RPC under the hood, right? And the RPC is an HTTP server. It's just not a REST server, right? So when you see how you interact with these things in CosmJS, you're going to go, oh, that's literally how I was encoding those JSON arguments when I was interacting with it via the CLI. And this is why, because under the hood, the CLI is just passing those arguments to the RPC. And then because we're giving that output JSON flag, we're also getting them back as JSON, okay? So we're going to build on that knowledge later. But the main thing to really take away is that we've basically covered off this very simple life cycle, right? Query, execute, or really execute, query. And then the only thing that is really outside, so execute and query obviously are stateless, and the state is what is kind of underneath. That's in all computation. It's just like, all computation is like, constants or variables, functions, and then state, which is held externally to the runtime environment, which is important when you come to actually work and build and deploy a protocol, because a lot of your value will be locked in state, which I actually noticed there's a couple of. So we're going to wrap up. If you've got any questions, stick them in the chat and we'll go through them.
So I've been answering some in the chat, but I kind of want to say them as well because I don't know if YouTube has chat replay. So I just want to make sure that
it does replay the chat, but not. It takes a few hours, I think, for the chat replay to come up.
So I'm going to quickly rattle through the existing ones. So Sporthy asks, can anybody instantiate any uploaded contract? Like, can I too instantiate the Who Am I contract and it'll be like a copy of functionality? Yes, you can, as long as you set it up correctly with the instantiate message. That is completely possible. And
Yeah,
then
but didn't somebody do that for Juno? Is it like Marble
yeah,
DAO? Marble DAO is Juno swap?
Marble DAO forked Juno swap. Yeah, very like
Yeah.
literally as soon, even the front end, as soon as it was up. And then follow up. I haven't gone through the Unity contract, but could there be any issues if someone resets our code ID? No, because it would just basically create an empty escrow, which could be controlled by governance. It would just have no funds in it. And
Yeah. So
then
back to what we were just saying there, the key differentiator outside the runtime environment is state, and that's very, very different. That's a different kettle of fish. So, the reason that you've not whichever one we were just talking about that forked JunoSwap, the reason people use JunoSwap and not the other one is because JunoSwap has state that is like, we have loads and loads of people doing swaps, and these LP pools that have state, and that's where the value of the protocol lies. So
yeah. And then another one, if you have multiple instances of the same contract, how can you identify the instance that you need? Is it using the label that was defined? So there's kind of two ways here. I noted in the chat the ways we do it for how we have a doc where we just note down the contract addresses and we just have the dates of each release. You can also use the labels I talked about earlier. You might want to put the versioning number in your label. That's also a way to help identify it, but contract address will be unique. And you yourself are responsible for setting an informative label, but you could also set a really unhelpful label.
And the final thing is bytecode as well. So for the Unity contract, it as a CI step publishes its own checksums via CI. So if you get the bytecode off chain and then run the checksum command over it, you will get the same checksum back. So that's another really good way of checking whether it is the same bytecode and the same version as the thing you thought it was. But yeah, I mean, like Callum says, it's probably a smart, I mean, we can't tell you what to do, but it's probably a smart idea to put a semantic version tag in the label. And we'll maybe, if we ever do migrations, maybe we'll talk about some of the strategies for that as well, because that's another.
Yeah. And then what would make the OG Unity contract a real version as opposed to second instantiation? Like what makes a difference? As Frey said, the state, there's two completely different contracts, as in context, not contracts. One has the state of it has the funds. The other one is one you've just spun up and it's empty, unless you funded it for some reason, in which case, goodbye funds. It would be hard pushing for a governance prop to say, can I have my funds back? I accidentally reinstantiated the Unity contract and sent 10 Juno there. But hey, if you want to do that, go for it. It's a permissionless network after all. And the Sporfies also suggested that one day we could do a breakdown of the Unity contract. I'd be interested to do that. I don't know about you, Frey. You might be sick of it, to be fair.
There is a game of nodes.
Yeah, that was what I was also going to point at. There was a lot of diagrams by Jabby.
It's not done at necessarily at code level, but it is a breakdown of the full functionality. There's also a blog post, which I will go and find, which tells you how it works.
Yeah, and then while Fred's doing that, I'll keep on rattling off the questions here. So Andre asked, this is probably stupid, but let's say I want to fork JunoSwap. I can instantiate the JSwap contract without and even deploy mine, then point the front end to my instances. Yes, this is exactly what Marble DAO done with Marble Dex. They even forked the front end and just had their own LP pools. There is the code ID for the LP pools for JunoSwap is publicly available in their docs, because even if you want to add a pool to the actual JunoSwap, you have to create your own contract, and that's documented. I think the code ID is I'm blanking on it, but it's there in the JunoSwap docs, because if you want to create a pool anyway, you need to create your own pool. So when we launch HOW, that is something that will need to be done. And then another question from Ali. Please, can you talk a little bit about attributes? I'm going to assume that means the attributes in that log there, which you can effectively set in the code, and you can attach sort of strings, and it's like a map. So as you can see in there, you have the sender key value and you have the underscore contract address. If you want to, you can add your own custom attributes, and this is quite often encouraged as it sort of allows some sort of mining on the front end to check that everything's as is. You can use attributes. So you can see here a custom attribute is added for the method, which is effectively what endpoint are we calling, and it just puts instantiate. So you could then fire this off and then you'd get back in the attribute method instantiate. You can then also see in the try_increment function, it has method try_increment because you're hitting the try_increment endpoint. So it's just there to sort of give a little bit of additional metadata that can be quite helpful sometimes.
Okay, cool. Very well explained. So if there aren't any other questions, we'll wrap it up there. If you have any before our next one, you can get hold of us on Twitter. Callum is Callum and one doxed, which I'll just put in the chat. And that's mine. And yeah, just ask us questions. We'll cover them off in the next one. Next one, we're going to be doing essentially like writing. Basically, you can use this template we've used today to create a completely sparse open template with nothing in it. And I think Callum has done a tier list contract, which we are going to kind of re-implement. It's going to be a little bit, here's one I made earlier, and a little bit, we're going to try and get VS Code sharing working so that we can both be like grumpy old men stepping on each other's toes while we write it, which should be fun. So we'll post on Twitter when I don't think it'll be next week because
I'm in a foreign country next
Callum
week.
is touching
so,
grass.
Yeah.
So that's cool. But probably the week after we will do that, and then that will complete this first cycle of like very basic.
The trilogy, the original trilogy.
The original trilogy of CW version 1 tutorials. And from there, we're going to do some more stuff. We'll dig into CosmJS. And again, if you have questions and sort of things you want to see, then shout them out. We could even do one on the Unity contract and future stuff like that, pseudo endpoints. Reply, actually, to be fair, pseudo reply and migrate, which are the three other endpoints we haven't really talked about. I think we might, once we're done with the original trilogy, we might go and talk about those because they're quite common behavior you'll want, but the documentation, if you're not already used to working with these contracts, can be a bit hard to get your head around. So it might be useful for us to go over this. So maybe we'll do that.
Yeah.
Great. Okay. Right. Well, thanks for joining us, everybody, and we'll catch you in the next one.